Something is building in the Pacific Ocean right now that the people who study these things for a living are describing with words they don't normally use. Code red. Never seen in modern history. Off the charts. One chief meteorologist and climate specialist put it this way: we're going to see weather events that we've never seen in modern history before. That is not a YouTube thumbnail exaggeration. That is a quote from a broadcast meteorologist describing what NOAA, the ECMWF, Europe's most respected long-range forecasting body, and the World Meteorological Organization are all converging on in their current models. A super El Niño is developing in the tropical Pacific. It is already confirmed, and the current trajectory suggests it may be the strongest one in over 150 years, possibly the strongest in the entire modern instrumental record. In the UK, which has already had, let's go through exactly what is happening, why this one is different from anything in living memory, and what it means specifically. Eye for temperatures and weather across the United Kingdom in the months and years ahead. First, you need to understand what El Niño actually is, because the name gets thrown around a lot and the mechanism behind it matters for understanding why this one is so alarming. El Niño is part of a naturally occurring climate oscillation called the El Niño, the Eastern Pacific, off the coast of South America. Relatively cool. During El Niño, those trade winds weaken or reverse. The warm water that was being pushed west stops being pushed, and it sloshes back east across the Pacific. Sea surface temperatures in the central and eastern equatorial Pacific rise significantly above average, and that enormous pulse of oceanic heat vents into the atmosphere above it, altering atmospheric circulation patterns globally, shifting the jet stream, redirecting storm tracks, redistributing rainfall, and raising global average temperatures for months to years afterward. The World Meteorological Organization uses a simple threshold to identify El Niño, sea surface temperature anomalies in a specific monitoring region called Niño 3.4 must exceed 0.5 degrees Celsius above average for a sustained period. A moderate event exceeds 1 degree. A strong event exceeds 1.5 degrees. A super El Niño, a term used by some agencies and rejected by others as too informal, but now widely applied in scientific commentary, is recognized when anomalies exceed 2 degrees. The strongest event in the modern instrumental record was 2015 to 2016, which peaked at approximately 2.6 degrees Celsius above average. Before that, the 1997 to 1998 event was comparable, and it produced, among other things, the warmest year on record at the time and a cascade of extreme weather events across every continent. What is being forecast for late 2026 into early 2027 is not 2.6 degrees. The ECMWF's most recent ensemble runs project median anomalies approaching 3 degrees Celsius in the Niño 3.4 region by the December to January peak window, with high-end scenarios pushing toward 4 to 4.5 degrees. The ECMWF's probability tracker went from 22% in March to 80% in April to 100% probability of a super event in May, a rate of escalation faster than the buildup to either 1997 or 2015. NOAA's Climate Prediction Center officially issued an El Niño advisory on June 11, 2026, confirming that El Niño conditions are present and expected to strengthen through winter. CPC now rates the probability of a very strong event, one that would rank among the largest in the historical record going back to 1950, at 63% for the November to January window. For context on what a 3-degree anomaly would actually mean, the only previous event that may have approached this level was the El Niño of 1877 to 1878. Estimated from proxy records rather than direct ocean measurements. That event, the strongest in the pre-instrumental period, coincided with catastrophic global famines across India, China, and Brazil that historians estimate killed between 12 and 50 million people. Modern agricultural systems are far more resilient, and the comparison is not meant to, driven by oceanic warming at roughly the same magnitude as what the models are now projecting for late 2026. The engine behind this event is a massive subsurface Kelvin wave. A Kelvin wave, in oceanographic terms, is a pulse of anomalously warm water that travels below the ocean surface eastward across the Pacific. It was triggered earlier this year by a rare triplet of tropical cyclones in the western Pacific that produced strong westerly wind bursts, temporarily reversing the trade winds and mechanically pushing warm surface water eastward while simultaneously pushing warm water downward to propagate as a subsurface pulse. As of early June, the subsurface temperature anomalies in the eastern Pacific were running at more than 6 degrees Celsius above average at depths, between 50 and 250 meters. The comparisons being made in published ocean analyses are direct. The 2026 Kelvin wave is tracking warmer at this stage of development than either the 1997 or the 2015 event at the same point in their evolution. And critically, The Western Pacific is still warmer than in those previous events, suggesting the subsurface heat supply has not yet been fully released. NASA satellite data has confirmed a major sea level height anomaly along the tropical Pacific. Warm water expands and raises sea level. So the satellite signal provides an independent confirmation of the massive subsurface heat content building below the surface. Former NOAA chief scientist Ryan Mao has called it Code Red. ECMWF modelers stated in early June 2026 that the current trajectory suggests this could become the strongest El Niño ever recorded. Live Science reported in early June that ECMWF predicts this will be the strongest ever recorded. The Fox Forecast Center noted that an El Niño of this caliber being predicted with this confidence this early in the season means it could be an event meteorologists reference for decades. Now, a critical caveat that every serious scientist in this space emphasizes: forecasting ENSO strength this far in advance carries genuine uncertainty. Every El Niño is different. The 1997 to 1998 event and the 2015 to 2016 event were roughly comparable in Pacific anomaly strength, but their weather impacts across different regions were substantially different. The 1997 event dumped record rainfall in California. The 2015 event largely missed it. Same. Classification, completely different regional outcomes. What the models are telling us right now about peak anomaly magnitude could verify, or it could fall short of the most extreme projections. Many experts, including those at the Met Office, characterize the current consensus as pointing to a very strong event while stopping short of definitively calling it a guaranteed historic outlier. What is not uncertain is that El Niño conditions are present, are strengthening, and are expected to intensify significantly through the autumn and into the winter of 2026 to 2027. The WMO gives a 90% probability that El Niño will be established before the end of 2026. The disagreement among forecasters is not about whether this will be a major event, it will be, but about exactly how far into record territory it will push. The honest answer, which the Met Office itself has been careful to state accurately, is that El Niño's effects on the UK are real, but El Niño was declared in June 2026, states that El Niño can increase the likelihood of more unsettled conditions later in the year, including a higher chance of milder, wetter, and windier weather during autumn and early winter, and that it can also be associated with colder and calmer late winter periods. These are probability shifts, not certainties, and their specific manifestation depends heavily on the Atlantic that operates somewhat independently of Pacific ENSO dynamics. But here is where it becomes genuinely consequential for UK temperatures, and for global temperatures that ultimately feed back into UK summers. El Niño events push heat from the ocean into the atmosphere, raising global average temperatures significantly above the underlying trend. The 2015 to 2016 event made 2016 the hottest year on record at the time. A typical strong El Niño adds roughly 0.2 degrees Celsius to global average temperature above the long-term warming trend. A super El Niño at the scale currently being projected could add substantially more, and it will do so on top of a baseline that is itself already the warmest in the modern instrumental record. The Met Office's own annual forecast report, produced in its role as the WMO lead center for annual to decada, climate prediction, states directly that there is an 86% chance that 1 year between 2026 and 2030 will surpass 2024 as the warmest year on record. Dr. Leon Hermansen, the lead author of that report, said explicitly, "There is an El Niño predicted for the end of 2026, which increases the chances of the following year, 2027, being the next record-breaking year." That trajectory, this summer already historically hot, the El Niño peaking in late 2026 and early 2027, the heat, its releases into the atmosphere flowing through into 2027's baseline global temperature, is what connects the distant Pacific Ocean to the UK thermometer. The Toro investigator Simon Culling, who has been tracking the developing ENSO signal carefully, has suggested that the event could lead to hotter summers in both 2026 and 2027, as well as an increased risk of a significant cold spell during the winter of 2026 to 2027. That cold spell signal in late winter is consistent with historical El Niño patterns over the UK, where the warming effect in autumn often gives way to cold, blocked patterns in January and February as the atmospheric response evolves. It is, in other words, not a simple story of El Niño equals warmer weather always. It is a story of intensified variability, extremes pushed further in both directions, more dramatically, for longer. The already exceptional summer of 2026 in the UK provides important context for understanding what the El Niño background means in practice. The spring of 2026 was already the warmest on record for England and Wales before El Niño fully developed. The first heat wave of the year broke the May temperature record twice in consecutive days. The second broke the June record at 37.7 degrees Celsius in Lingwood, Norfolk. May figure that is the 6th highest temperature ever recorded in the UK in any month of any year. The third heatwave, currently in progress, is the third separate declared event before mid-July. And crucially, the European seas surrounding the UK have been running significantly warmer than average all summer. Marine temperature anomaly maps from late June 2026 show the waters around Britain and Ireland well above their long-term averages, and warmer seas feed directly into the intensity of heat events by supplying moisture and reducing the modifying effect that cooler coastal waters normally provide. The WMO's Global Seasonal Climate Update confirms that for the summer period, almost all regions globally are expected to experience above normal temperatures, with the signal in Europe and Northern Africa particularly strong. And high-pressure systems over Central Europe and the British Isles, the same Azores high that has anchored this summer's heat, are specifically flagged in long-range analyses as more likely to persist through the summer season under a developing Super El Niño pattern. What this adds up to, taken together and stated plainly, is this. The UK is experiencing an already exceptional summer that has broken multiple records. That summer is being shaped by a displaced jet stream and an unusually persistent Azores high. Those atmospheric conditions are being reinforced and extended by a developing Super El Niño in the Pacific that has been officially confirmed, is still strengthening, and is projected by multiple independent forecasting bodies to peak at strengths not seen in living memory. The full heat signal from that oceanic event will not reach the global atmosphere immediately. It builds and releases over months, with the most pronounced effects typically in the second half of the event and in the year that follows, which means 2027 could, on the current trajectory, be even hotter globally than 2026, and 2026 is already tracking as one of the hottest years in the historical record. The Met Office has confirmed that annual global mean near-surface temperatures for 2026 through 2030 are predicted to range between 1.3 and 1.9 degrees Celsius above the pre-industrial 1850 to 1900 average. The warmest spring on record for England and Wales has already been logged. The June temperature record for the UK is already gone. And the subsurface Kelvin wave that is still propagating east across the Pacific has not yet fully surfaced. There is a reasonable debate among serious scientists about exactly how extreme this event will ultimately verify. The models have been consistently revising upward with each new run through the spring and summer. Former NOAA chief scientist Ryan Maue's Code Red label reflects the concerns of people who track these systems professionally, not fringe commentary. But there is also genuine scientific caution about equating a model projection in June with a verified record in December. El Niño forecasting at peak precision requires atmospheric conditions to cooperate with the oceanic signal, and those conditions are not fully predictable months in advance. What is not debatable is the directionality. The development is occurring, it is strengthening. The subsurface heat reservoir in the Pacific is among the largest documented in the observational record. And it is building on top of a baseline global temperature that is itself the warmest in recorded history. The combination of those two things, a record-warm baseline plus a potentially record-strong El Niño pulse on top of it, is what makes the meteorologists who study this say they expect weather events they have never seen before. For the UK, this summer has already provided a foretaste, 3 heat waves. Records from May through June, a third event still running in July. The El Niño that is about to push those anomalies even higher has not yet peaked. Its atmospheric fingerprint is just beginning to emerge in the jet stream patterns and pressure distributions that will shape what autumn, winter, and next summer look like for everyone in these islands. Subscribe and stay with this channel, because the story of what this El Niño does to UK weather is going to run through the rest of 2026, through winter, and well into 2027. And based on everything the data is showing right now, it is a story with a very long way still to go.